All right, hello, nobody. But Monday night stream here, public holiday. So what we're going into tonight is these last three parts here, and then we'll have a look to see if there's any other duplicate parts we need to set up for our assembly, because I think we might have by this point modeled everything. But I'm keen to get through these three as quick as we can. And if not start the assembly process in this stream, probably set that aside for the very next stream to do. So get everything ready so we can do the whole assembly in one stream together. And before doing that, I'll make all the files shareable so everyone can jump on and have a go at the same time. It won't be a race, but at least something that multiple people can have a go at. So let's get into this one. We're going to start with this sort of yellow panel part. The name of that is, let's see, the yellow Technic panel curved. So jump into there. Completely new part for us, of course. This is different. I've got an error. One of my drives is remapped. Let's have a look. That one, G drive. Interesting. I'll fix that one up tomorrow. My Lego is still working though, so that's all good. I'm going to start with one of these parts. Now I have not done this one before. It is completely new. What I'm looking at here is all right. I realized I should not use that camera without this head on because we do not get any audio. So here's the part that we're going to be doing. This is the yellow panel. It is nearly symmetrical. We may do appearance labels later. Probably not going to do them at this point. So we can imagine without that. It's got this sort of consistent wall across here. It's got an edge on both sides. It's got a couple of smaller points here with some material taken out. These pin areas on both sides, they are to be sort of standard. You know, there's a small recess lip inside there, but on this side there's a bit of a cut away, top and bottom. So we'll do that for both parts as well. Let's jump into it. Hello, internet, whoever is there. Now, tricky part, how does this fit into the assembly? Let's just have a look at that to see how we might go about modeling it. For that, I'm just going to have a look at the instruction. And I can see that it's positioned, if we even look at this picture here, it's on the left-hand side there. And that front face that we're looking at, you can see it in this image here, this one goes straight up. So I think if we put the origin down at this pin here, and use that as our sort of reference shape, that's going to match well with our assembly. So calipers I've got today, just back to the analog ones. The battery of the other one was no good. I'm going to start on the right plane, and we're going to draw this pin at the bottom. So that's got an outer diameter of 7.2, inner diameter 4.8. And we're going to try and get most of the geometry in this shape. So let me just zoom in on that part for us. Okay. So that has, look, at least the sides are flat. We'll do this later with an extrude, but they're flat across there, so that's neat. Why don't I put that other hole in, even though we don't know the exact position yet? So I'm just going to put another 2 circles over here on the right. Make the inner and outer equal. And do I dare doing an X and Y dimension for this? Well, we might have to. I'm wondering if there's probably a very standard dimension that's between those 2 points. If I eyeball it, it's going to be close to 30, 32. As in the same as, like, let's have a look at an example here. We've got some reference parts. So we can use other parts here to give us a guide on how big it is. If I was to use this green one to line up that top hole, and then this black one to line up those bottom holes. And I think this is in the name of the file, the name of the part as well, where it says this one is a curved 3x5 by 3. So stud dimension, 3x5 by 3. Yeah, but it comes down 4 studs. It's 5 across, 4 down. Which would be 32, because we go in 8mm increments. So, 5, sorry. 8, 8, 8, 8. Yep, 32. And 3 high would be 24. Okay, that's what I really like about this Lego system. Once you work out basic dimensions, it's easy to sort of join things together. So that's going to save me a lot of mucking around. Now we can put the front on. So the front is obviously tangent with this face here, which means it's coming up nice and straight from here. And if I just draw it as a straight line, come up to that next. This bit is also tangent, so that comes off horizontally and then curves down. This one, whereas this face here has the very flat, use this as a guide, it's very flat section. This one on the top side does not. You can see pretty quickly it starts curling away from that line. That means when I draw it here, I'm going to grab these tools. I'm going to bring that to tangent, and then bring the height of this one up. Now, I'm going to use my radius measuring tools. Just a couple of them there. Let me show you these. Here's a little kit that I got the inspiration for from someone else on Bands or one of the 3D print places. I've printed a few little radius gauges. Okay, so R6, which means that's R6 and that's R6. And this can help me find what that radius is on that top edge. So you can see it's bigger than that. Sorry, it's smaller. So it's probably around 3 millimeters. And what I can do is put this radius here and here. I can see, look, that looks like a pretty good fit. So R4 for that fillet. Now, I don't need that till later, but what it helps me know is that the radius or the point here that I'm trying to sketch to is 4 millimeters away from where the curve is. I'm going to use that in a second. So R4, that's very handy to know. When I'm trying to estimate curves like this, what I'm doing is measuring, in this case, the flat section, and then using my eye, I'm going to where that curve intersection point is between the flat and the tangent curve on the top. And in this example, it's coming out about here. It's around 18 millimeters. So if I put this curve to 18, and then I put a 4 mil radius in, that's approximately the shape that I'm looking at with this part. We might do a 3D print later of this to see how accurate we are, but that's pretty good for now. Right, what other detail do we want to get in this view? Probably not much. It's a good starting point to set us up for the model. I'm going to now do an extrude. I'm going to extrude these 2 pins either side, the round areas. I'm going to suggest they're going to be 8. They're right on, 7.8 millimeters. So E for extrude for me, I'm going to select them, those contours. I am going to go one direction, because this is almost symmetrical apart from the end. We'll do one whole side, all the detail, and then mirror the entire body. So 4 millimeters. Sorry, it's going to be 3.9 millimeters. Okay. Let's do the rest of that. Let's do the rest of this shape now. Join those up. We're going to do a new sketch on the right plane. We're going to convert these edges, and we're going to look at the thickness of the main section. So not these edges, which are thicker, but the main section here. We'll do that edge afterwards. So to get the thickness of this main section, I'm going to assume that these edges, where it's a little bit thinner here, is consistent all the way through. So coming here, get my calipers. Now I'm getting about 1.4 millimeters. You can see on the other end, looks a little bit thicker. 1.5. Let's use 1.5. You know, offset 1.5. Grab that edge, bring it down. Now, looking at the detail, I can see as well that this section, the section I'm drawing, starts a bit higher. It doesn't start right here where I've drawn it. It's definitely higher. What I can do for that is look to my, could measure this way, not quite. I think I'll go from the center point. Is it guidelines? So 4 millimeters. I think it's going to be consistent. This one's got a bit of an angle to it. Four millimeters. All right, so the bottom one's easy. This one here, 4 millimeters from the origin. This one, so at this end it's got we're going to assume it's vertical, it's so close. I'm just going to draw a vertical line and then dimension from that center. 4, there's our shape. And then we've got our thickness. 23.8. So when we're doing something like this, we're only going half. We can put in 23.8 and then use formulas, in this case divided by 2, to get half the width. All right, another step done. So if we're looking at the joining detail, so in here we can see that there's a couple of ribs, a bit of a round dot there, a bit of thickened plastic. This side's just one rib. We'll do that later. If we look at this very edge, you can see there's a bit of plastic that continues from this circle, the tangency out, and goes into that plastic at the same thickness. And that's going to be consistent on both sides. So how that looks. We're going to, again, jump on the right plane. We're going to use the original sketch as reference. I'm going to convert that edge. I'm going to sketch down. I'm also going to convert the bottom edge and convert this circle. And just use the trim tool to get the shape that I need, which is that section in between. Once I've done that for the top, I'm also going to do that for the bottom. This is easier because it's all straight, so I'm going to convert those two, sketch that down, trim, and now I can extrude. And I'm going to extrude up to surface, which is going to be this face. So then it's doing that exact width, and it's going to merge all the bodies together now. Cool. All right, so now we can refine that join, so what it looks like, because we can see if we focus on this one, you can see the rib, but there's also plastic filling in. It's kind of flat, hard to see. The face here goes straight down to that, whereas this one you can see at the moment we've got an undercut where there's this gap. I've been my undercut. See all this red section? That's currently an undercut. So in the real model, that I've got in my hands, there's no undercut there, that plastic's filled in. Now we can fill that in the previous sketch. AMQ, welcome back. Feel free to drop in your question. So how I'm going to do this one, I'm going to extend a point from here up and extend the converted edge down. I'm going to make those two tangents, and then you see that's fully defined, and that's going to fill in that area where there was an undercut. At the bottom, I'm going to do the same thing but horizontal. So I'm going to grab this point, put it across, trim around, through and make tangent. And now that fills in those areas for me. So now if I look at undercut, well, there's no red section here. There's, yes, 0 draft. That is something that would be changed in production, but no undercut there. While we're here, let's save this part. 24116. Very good. Okay, progress is good on this. Let's now do, should we do the rib? Yes, we'll do the rib on the bottom. I think that singular rib down here, we can measure that rib. It's right on 1 millimeter. The size of the rib, I'm going to estimate around 3 millimeters. On my right plane, we're having a look. Something like this. Go 3 by 2, and just going to extrude that 0.5 millimeter. All right, that fills in that rib on that side. On the top side, there's 2 ribs, and that round sort of section there, which is the reverse of the injection point. Let's do the ribs first. Now these ribs, they are each a millimeter thick, and they are combined 5.5 apart on the outside. All right, so we're going to use that measurement to put them in. So what this looks like, I'm going to draw this shape. Now this one I don't want to cut the angle. I'm going to draw out. I'm going to draw it down into here. NQ you can try. I can open an image off screen to have a look at something. Okay, so I've got that section. Now that's coming down about 4 millimeters. And then that rib at the bottom, about 3 across. All right, now how we do this one, I said we're going out 5.5, and it's 1 millimeter thick. So 1 millimeter for thickness. And then from, I'm going to go 5.5 divided by 2. And just make sure my direction is going the right way. And there's that rib. All right. Now the cut that I talked about earlier, that's different in these two parts. It's on one side only. We don't put that detail in until we've already mirrored the body. So that comes later. All right, so next we do this wall on the side. For that one, we're going to do a sketch on the outer face. I'm going to hide the original sketch. I'm going to select tangency to convert that edge. And now this is where I can measure the thickness. So we can see at the end, it's got a consistent thickness across this edge, but then when it gets to the end, it tapers off, so it gets thinner. And here it's got like a flat edge and it gets thinner. So the main thickness is 3 millimeters. At the end, it's just under 2. This end, right on 2, just about 3. Okay. So what we'll do is offset this 3 millimeters inside. Then here we're going to go across 2 millimeters and then up. And we're going to go up. What we estimate here is 6. Trim that section. And then at this end, we're going to come down 2 millimeters. Now this one, again, it's got a flat section there, but it's a lot more subtle. I think what we'll do is the same dimension, 6 millimeters, trim. So then we have our edge. If we measure the thickness of that edge, it's 2 millimeters. I'm going to extrude, make that 2, reverse direction, and okay. Now we've got that detail, so we're nearly there. Okay, in Q, not sure how to create a pattern. I didn't get your link. This diamond shaped core, I mean, I can create a teardrop like shape and go real pattern, but yeah. So if you tried pasting the link, it hasn't worked. One way that you can chat directly with me is through LinkedIn. I'll give you my link. You can send me a message. I'm also on Discord, but I do not have my own Discord channel. So that can be difficult, but we might look at something like that if this becomes a regular thing. Yeah, so the link hasn't come through, but I'll see if I can post a link, which I can. Feel free to jump on, connect, and send me a message. And then I can have a look for you. The one Discord, SolidWorks Discord or CAD Discord, you can mostly find me in is Too Tall Tobies. All right, back to the part. Now we've done most of the detail. The injection point on the top, because it's quite visible, I think we should do that detail. So let's put that in. We can measure a diameter for that. and then 4 millimeters. The depth, I'm just going to guess. It's quite a kind of difficult position. And it's also pointing at an angle. The center point of that is roughly 7 millimeters off that circle. So I'll show you how I do this detail. That as a construction line. I'm going to do a 3-point center rectangle like this. I'm going to put the middle of the rectangle on the edge. I'm going to do a line from the center point to the bottom. I'm going to do a line from the middle to the side. I'm going to make this is all construction. It's all just setting it up, and there are multiple ways of doing this. But I'm just trying to get an edge. I'm trying to get a box which is going to match, you know, the alignment of that top edge. Because what I said is that from this point here to this point looks like about 7 millimeters. I don't actually need the line. I can just use that center point. What I can do now is use this as a depth guide. So let's say I think the depth of that groove is about 0.5 of a millimeter. And the width of it, we measured 4 millimeters. I'll put these dimensions in. 4. All right, now I'm going to do because it's rounded at the bottom, there's a couple ways of doing that. I'm going to do that with the dome afterwards. So all I'm going to do here is use the construction geometry I've created to create a rectangle that's matching those, and do a revolve cut like this. And then in the bottom of the revolve cut, this is the part I'm not sure it's going to work because I've only got a semicircle, but I want to do a dome. I don't think it's going to work on a half size. So I think I'm better off putting that into the revolve cut. And to do that, I'm just going to grab this tool. So I'm doing an arc. I'm putting the arc in line with this construction line, making sure this comes down and this joins up. And the depth of that, 0.4. Change that to for construction. All right, now the dome is in that cut. Right, neat little tool trick there to get that detail. What we want to do on the reverse side is, you know, see that bump? I'm going to get something like that in there. So a very simple way of doing that usually is to offset that face to whatever thickness. Now that, does it go through the ribs? It does, right? You can see that detail. Let me just go big here for you. Cool, mate. Let me open Discord and check it out. So just looking at this detail, we can see that the disc, this bulb goes through that rib And so now if you have a look at my CAD, when I'm doing this surface offset, and I bump that up, that's also going to go through the rib. 1.5 mil would indicate pretty similar to the thickness that we did for this main section, 1.5 mil. So I can grab that surface offset and do a thicken. Just want to thicken it down to 1.5. All right, so it's kind of worked. Can I delete this face to remove the undercut? No, not quite. Hey MQ, I am just having a look at my Discord. I do not have any messages waiting that I can see. Apologies, I'll have to sort something out. But this is a great prompt for me to do so. So people can message me other stuff during live streams. I'm not an expert at Discord, so if I have missed it, I apologize, but I cannot see a message there. No, I am not Too Tall Toby. That is not my Discord. Yeah. Toby is a friend. I follow along his channel, jump in his community, but that is Toby Schnars from Too Tall Toby. My name is Chris. You can find me on Toby's channel as Chris B. Co. But yeah, I'm not sure how well that works. Yeah, Toby has shared some of my streams and some of my videos before because I do enjoy his content and promote speed modeling. So yeah, goes around in a bit of a circle. I see a lot of benefits for speed modeling for designers and engineers, so I highly recommend it. All right, back to this detail. So what I want to do now is work out a better way of getting this round section without having that undercut. Another way I could try and do it is to offset this surface here at 0 and then use that one to thicken up. I think it's going to create the same detail. Yeah. How can I change it? I could go bigger and then do another fillet on that top edge. That's probably the easiest way of doing it. So delete these ones that I've done here. Grab this one, do a fillet. 0.5, 0.5. I think that's pretty neat solution that puts in this dome section for us. It's not perfect. Actually, that's probably the way to do it here. Let's do a surface offset, but include, I want to go 1.5, but include that face. There we go. Now it moves all the way out. How can I do this more easily? Let's bring it back down to 0. Do the same thicken. Good. I have to just delete the faces on this side here, which I can do. But I will no longer need that fillet. That goes. And I can grab these edges and do a delete face. Like this. Cool. All right, that's pretty neat. All right, other detail on this part. Yeah, other detail on this part, we've got these sort of little cutaway areas on the sides here. These bits. Now, I am not 100% sure what they're there for. Normally I might say like coring, removing some thickness from the material, but they're so thin. Don't know about them. I don't think there's actually any value of me putting them in this model. So we'll skip that. It's got a couple of fillets. So it's got a little radius here. We'll put that in. So that's at the tall edge up here. So I put a 1mm there. I think it'll have the same at the other end. Down here. Put that in. It could even be a bit bigger. 1.5. And then on the outside, we have that normal sort of cut detail where it steps down. So we're going to do that. So that wall, it's like a 0.5mm wall, I believe. So on this face, going to do 6, leave it 6. 2 sketches, extruded cut, 0.5mm. I think we might have to tweak that later. It might be more. 0.8. We'll see. All right, so I think we're at the part to mirror this. At the point to mirror, so I select the face, select mirror, select body, merge, and OK. It's looking good. This part's looking a little bit deep than it should. So I'm going to reduce this thickness. It's still okay. And now we can do the cut. So the cut I'm referring to is when we look at this part, turn it over. On this side here, there's a cut away. Now on this side. And that cut makes this side, the thickness of this only 7mm. And the cut, as you can see here, it's like a semicircle. Right? And it cuts away all that bottom material because it gets so thin from the wall. So all this section here, all of that thickness is cut away. That's actually a way that we can measure the depth of that pin, because we can say, hey, the whole thing is like 7.8, all right? But without this side, it comes down to 7, which means, well, it's taken off 0.8 there. That cut is also 0.8. So we were right in that estimate. So the detail on the outside face, I think this is very easy, that we grab this edge here and we do a rectangle over the top, make that tangent, and do the same at the bottom, which is conveniently on the origin. Cool. Extrude cut up to surface, this face. There we go. bring it into the assembly and give it the yellow color. Another piece. Tick off the list. You guys happy with that? Anyone watching? I think we got all the detail we need for that one. So now there's 2 left. All right, now I've got a message request. MQ, I'm going to assume that's you. Yep. All right, I've got your picture. All right, now your question. I'm not sure how to create a pattern like this. This diamond-shaped core. I create a teardrop-like shape and go radial pattern, but do you mind if I share this image? I'll just save it. Try and save it. I think we can do this pattern quite easily. Here we go. What's your question here? So it's not too difficult. Let me try and get that locked on screen. There we go. How to do this. Well, it's cut down, right? So it's material that's cut down. So you start with a shape that is solid. Okay. And then I'm going to use really small numbers, pretty small numbers. You've got a circle, 80. Then you've got a teardrop shape and a diamond shape. All right, so the diamond in the middle, so it's 20. And let's say that's vertical. So this is kind of like your guide to the size. And then use that to say do a pattern, cut, and then it's the diamond that is filling in the material. So what I actually imagine it looks like, say 6. Extruded cut. lined. Doesn't matter the thickness. I'm going to do 1 millimeter. And then that has a pattern. That is patterned equally over 360 degrees. I need an axis before I can do that. I haven't made one yet, so I'll just make one. So that's my axis. Use those to do a circular pattern. How many patterns are there? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 in a quadrant. 10, 11, 12, 13, 14, 15, 16. Let me try that again, because I think that's horizontal and that's horizontal. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's 24. Like this. Now I'm creating zero thickness geometry because I'm cutting to this point here. It's not the smartest thing, but I can tweak that. Right, so I'm going to change my cut and just move it a little bit off that point. So it's here, vertical. 5. Now when I try and do this at 360 degrees and 24 instances, okay, that's my cut. Now at the moment it doesn't look like your pattern, but when I grab this diamond and then fill that in, hide the sketch, we're getting closer. Now we just have to tweak the thickness of this cut. That's what's different. So this point needs to come up and the point needs to be different for each of those patterns. As you can see, like there's a point finishes here and here, but these points are all a little bit further in. The outside shape stays the same. Are you getting what I'm saying? Not actually a pattern. It's a cut here. Every cut's a little bit different though. So I'd have to use the diamond. I'd be doing it more like this, finishing the cut on the diamond. So you could do it like a variable sketch pattern. You do a variable feature pattern potentially. No. Like just for instance, the next one you do, we'd have a circle that's here. You have a line that goes, we're going to here, right? So that's tangent. The angle of that one is if there's 8 of them, I think that's going to be 45 degrees, right? That and that are equal. CSWA, extrude cut. So if I just pressed OK on this, you'll see how those are different. Change this. This is going to be do 4 of those patterns. Do you see how I've done that now? So now the points are at different positions. that is your answer, I believe. And then outside of that, it's just some circle cuts. We can finish this off very quickly. We can do, because most of it's a pattern, you only have to do a couple of instances, right? So these three are all for construction. They're each, is that right? We've got one, that's the 45 degrees. So then there's 1, 2, 3, 1, 2, 3. Yeah. Testing my maths here. Kind of. I'm doing it for you right now. You just need to set up each shape individually. And like the diamond is an important aspect of it. You want to make sure that you're not getting any relations incorrect. That's going to be a sticking point. Any incorrect relations is going to ruin your geometry. Because when you've got all these different edges going, like they can stick at different places that you don't mean. Okay, but now, so we do one section like that. The next section, I think, can we mirror? I want to mirror that one, but I want to mirror that and that. I'm going to mirror it about here. See that? I think we got it. I'd say hello. Connect all 5 circle centers with construction lines, make them equal. Yeah. Good. But in the end, this is what we've done. So we do a vertical, the vertical pattern, we have to have the diamond as a construction geometry guide. And then in a cut, we do one section here, and then every subsequent section goes to that diamond endpoint, but the outside circle is the same. But because they start small, get bigger to the biggest, and then get small again, we mirror those other 3 on the end. So you only have to draw 1, 2, 3, 4, 5 sections, and you're done, and the rest can be a pattern. No worries. Nice little challenge. Should I save this? Let's see. Never know where we might need that. All right. Cool. Thanks for that. That was fun. Now, let's get on to these next 2 parts. We'll see what we can do in the next 50 minutes. I'm not going to have a late night. I've got work tomorrow. We have done something like this before. So before we go too far into this, I want to open those ones up to see what there is that we can save some time on. Because our last project did have its own wheels. If we scroll through here, we can see one wheel here, which will open. This one looks very similar to the yellow one. And then the tyre, I think the tyre is completely different. I'm not expecting that to be very similar at all. If we can find it. I don't know why it looks like this. There we go. All right, so the tyre is completely different. There's not much we're going to learn from that one. This one is much simpler. So it's probably got the same kind of internal step here. It's very similar. We'll learn a little bit from the patterning, how that's done on the outside, but this is a much easier shape than this last one that we did. So close that. But this part, compared to this one, we can already see some similarities, right? And some differences, like this one has a through hole. This one's through and round, whereas that has the axle shape in it. That side profile. Similarities. Okay, this has this weird kind of slot through here. And the back detail. Similarities again, but different. So like we'll use this one as some reference, but we'll recreate this, I think, as a new part. Let's have a look at the Brinkley file. The wheel, we can see here. Hello, Jern. Thanks for dropping in. We're about to model this wheel, plastic wheel. There's a 3D guide here, which, look, these are always pretty rough. That's not bad though. I don't know what time zone you're in, Jern, but I know all about dealing with those time zone differences, given that 4 AM was my usual time for Model Monday Toby's competitions. All right, so let's just get going on this. So last time we modeled it, this is the process we went through. We did a revolve with quite an amount of detail in it. Now, just for comparison's sake, let's have a look at the dimensions. So this was a 17.4 millimeter diameter, the one we're measuring. It's very, very close. It's almost identical. And the width, the length of it from the very tip, this was 15. This one, end to end, it's 16, but it's got that extra sort of 1 millimeter on the back. Like from here to here, it's 15. I'd love to cut some corners with this one and use some of this geometry. Because I think we could reuse very quickly some of this stuff here. This was a tricky bit to do. So I had these two extrudes coming out to the side, which we then patterned and then used a revolve cut to get that surface down and inside on the face. Like if we have a look at this in detail, what's really interesting about it, you can see these edges here, they drop inside that plastic edge. So it's not smooth. There's actually, well, there was a bump in the other example of the part. This one, it's almost nothing there. I'm not sure if I could feel it. Maybe this one is different like that. They kind of taper a bit too, whereas in this one, do they taper? the example that I've got on screen? No, not really. That'll be interesting to tweak. Cut extrude, same. Billet, same. Let's use this and modify it. I'll show you how we go about that. So 55981. Save as. Okay. Done. Color, so we know what we're looking at. And let's go right back. So when we get a model like this that we're reusing, easiest way I would like to work with them is to roll back, use the feature rollback bar, feature tree rollback, roll right back up. So I'm only dealing with one step at a time. Then if anything changes and I get errors, I can just fix them one at a time instead of have a huge screen of red. Just means it's a bit quicker to deal with. So we're going to come in here, and first thing we're going to do is just check some of these dimensions. So it said 17.4 for the diameter. This is close to 17.6, but I'd rather leave it. It's so small a change. The ring on the front, 7.8. Yep, that's pretty good. That bit in the center, I don't know if I can get to that. No, I can't. So I'm going to stick with the 10mm dimension that you can see there. And then on the outside, that top section, 2mm, yes. The gap, 2. All that looks the same. All of that sort of chamfered edge. This one here. 5mm, 5.8, that's good. This wall, we had a diameter of 14.5. So this one's a bit bigger, 15 point. That means that wall's thinner on this one, 1 mil. Let's see, this one here had 1.45. Yep. Okay. Jen, I wonder if any of the Lego block databases support uploading STL step files. Possibly, like the one that I referred to is Bricklink. They've quite a big community. Look, I haven't gone all the way into it, but when I'm looking at these parts, in a lot of places they have like a 3D CAD that someone has created and uploaded. They're normally pretty rough. But I have not. Parts data of Aldraw is used. Yeah, I don't know much about this. I've never looked. Yeah, broken link. I've never looked too much into where that comes from. But I have a bit of an idea of maybe creating my own library at some point. We'll just see how big I go with this. I've already got, in a short space of time, 1 project, 1.5 projects. Like, yes, there's some duplicates here, but I've already got around 80 parts, and I've got a lot more Lego to go. If I have a look right now, I've modeled, getting close to 100 with a few duplicates. So around 90, 80 or 90 parts, but we can grow that very fast. All right, so back on the revolve. Now I think this is all pretty good, except the detail changes at the back, this section, where it doesn't have, like this one has a big solid wall that goes through it, all through the middle. As you can see, from the front to the back. Whereas this one's different. What I think I'd change is I remove this, and I remove this, and I can join this one up like out here. And do I cut the hole next? Let's think about it for a second. Like I want a hole going all the way through, which means I can actually move this off, but all my dimensions are coming from that point at the moment. What else? My 17.4, they're coming from this line. So I need to disconnect those two. So I'm just going to bring that out, put this on the origin, make this in line with the origin. Okay, but now I can move this edge independently. So that's a little trick that I found. If you've ever got like two lines like this that are connected and you want to separate them, if I just use power trim on one of them to disconnect, then I can move them independently without having to delete and redo all the relations. So now I can get the hole that's on the inside, which is usual 4.8. I can get that full length, which was 15.8. I think I have a 15 there, so this is going to stick out 0.8 at the back. And then just put that wall in, and that wall's going to go down into here. And that wall thickness on the outside of that section, 7.8. Oh, matches this. That makes sense. All right, so a neat little edit to the revolve, which means we've now got a lot of that detail there that we didn't have before. So now this front one's going to fail. That's okay, because I can change that. Don't need that sketch anymore. There is this sort of small recess there in the front. Just on 6mm, not unusual. And the depth of that, we're going to guess at 0.8 of a millimeter. So I change this to 0.8. And then I'm going to, same on the rear. I can use that sketch. I'm going to do a new extrude cut, but change the sketch face to this one, and then the direction. But I don't need to resketch or to convert anything. I'm just using the same one in a different place. My yellow color looks a bit funny. I'm just going to copy. No, it's the right color. It's just a bit dark. There we go. Very bright. Okay, let's keep rolling down. Now the front detail. That's there. Now I'm noticing in this version, very subtle difference. I think that these taper looks bigger, smaller. Is it? So 3.8 millimeters. But here it's definitely smaller, closer to 3. Cool. So I'm going to edit this sketch. I'm going to change that dimension. I have to remove these horizontal relations. I have to set this to 3.8. I have to make, let's make the inside ones horizontal. I have to bring that one in, and this one dimension of that. Go to 1 millimeter. Bring that one in. Does that work? And then the outside is 3.2. It's not quite at the right point, but we'll get there. All right, that looks better. Now at least it's got a bit of taper. Oh. All right, so the changes I just did here, just changed a few of the sketches so that these outside lines are now taper in and the inside ones remain horizontal. Sorry, I stuffed up that one. I'll have to come back to it. So that's going to look better on the pattern now. Are they 1 millimeter? Or are they a bit bigger? A little bit bigger as well. So that, I'll just bump that up to 1.2. Okay, and then we'll do our pattern, cut revolve. Now the cut revolve will change because it no longer looks like it's cutting into the part. That's what I've done here. Okay, great. That is what I've done. It's smooth to the edge. Awesome. All right. That is looking neat. I think the detail on the rear will be the same. Just have to update some lost references. Anything specific with the hole placement? It should be in line with the prongs, which means this one should be horizontal. It'll be a little bit more spaced out. Okay. Is that all the different detail? Oh, and then this slot. It's an interesting slot that goes all the way through, but we better put that in. Let's roll on the fillet. Keep the fillet. And then, so on the slot is in line with those. So it's going to be from the side that we do this slot. Right plane. And it's probably too thin to get in there. Yep. So we're going to do that by eye. It's up to 7 millimeters. And it's right on those edges. So I'm going to do a rectangle. There's some fillets there which are getting in the way. I'm going to select that face and this face. The rest I'm going to use the origin. So right click midpoint, make it horizontal to the origin and then give it dimension. Extrude through cut through both. How does that look? Looks a bit thin, if I'm honest. That's 10 millimeters on the outer diameter. I just can't get in there and measure. Maybe the cut's a little bit less. But that's pretty good now. Part is done. Save. And we're 11:30. I think we've just got enough time to do the tyre. Very nice. Have a look at our list. We have done panel curved. There's stickers at the back. Yeah, those are the stickers, I think. So we don't have to do those. Just grey them out. We've done the wheel. Got a couple of pins, Technic pins left, which I think are just duplicates. So the main one is that tyre. Let's do it. So we get into modeling the tyre. Let's have a look at the detail of that part. We have let's zoom in. Okay. All right, there's some text. Lego group. You just make it out. It's tiny, right? It's so thin. There is, I think that's a part number. The part number is 89201. Not sure if that matches. Definitely looks like a different number on this one. Anyway, not too worried about that. On the other side, no detail. So internally, it's got this bump, goes through the middle. That's what helps it locate on the wheel. And then you've got this tread. That one looks a bit different than the rest. Now it looks a bit deeper. This one tread deeper than the rest. Maybe. Definitely. But the rest of it's pretty consistent, so it's obviously staggered. Left, right, but it's just one level, not multiple levels like the other ones. So what I imagine is we do a revolve of the whole thing. We have to get this dimension right for the middle. We can do one of these cuts, pattern it, do one on the other side, just move the position around and then pattern it as well. And then maybe it's a couple of fillets and it should be done. Let's get into that. The tyre that we did last time, just for reference, how we built that. So we started with a revolve. It's a bit tricky with this shape. sort of internal pit was offset one side. We did a cut revolve for the tread. We did some fillets on that. We did a pattern. Then I split the model so that that bit on the revolve there, that comes back later, I think. Split the model, mirrored, staggered the pattern, combined it back, then added that bump back on, then did some coring, did a chamfer on this front edge, and then finished with the text. This time it's going to be much simpler in our new part. So front plane, two construction lines. We want to get our width. Very important when you're measuring sort of soft parts on the calipers, not to squeeze, right? So just get to contact 14 millimeters. Now I'm measuring to the solid face on the outside. So I'm ignoring the treads. The treads will come in later as a cut to remove material. So this is going to be 14. Oh, that's the wrong dimension. We'll have to fix that. Yeah. Because the wheel diameter, outer diameter. It's around 23.6. It's this that is 14. Let's now get that in the middle. The thickness of the outer part of the wheel, .2 millimeters. So what I'm going to do is just draw this in. 3.2. I'm going to assume, I'll measure it, that it's the same on both sides. I'm pretty certain. But it might even just be 3 millimeters. Pretty close. And then that drop in the middle, hard to see, but I can get like a depth to that. It's probably got an angle to it. It's about 5 millimeters in on both sides to a chamfered region. So these, there, these sections here are angled. All right, so it's like this. This is also going to be in the middle, so I'm just going to make that coincident. I'm going to make these equal. I've just said that this is about 5 millimeters. And then let's say the diameter at the very middle. It's around 16. So from here to here, 16. Looks pretty good. And the angle of that chamfer, let's go 45. And then I'm pretty happy with that. So this becomes a revolve. Okay, and that's the outside of my wheel. And at this point, I will save it. 89201. 24 by 14. Black. Copy the material. Just put it on. There we go. Okay. Step 1 done. Step 2 is the tread. So for the tread, you can approximately measure that width of the section in the middle, which is very thin. It's a millimeter. And then what's the width of one of these treads? About 2 millimeters. And the depth, I'm going to eyeball that. It's too small to measure, obviously. Let's go to the right plane. And how we're going to do this, we're going to convert the edge. For the depth, we're going to offset it. It's not much, it's tiny. 0.5 millimeter. Reverse that. The thickness, we're going to assume that it's in line with the center. So how to do this? Front, 2 lines, trim them. We just put a construction line in, it might be the easiest way. What I want to do is just get them all symmetrical, right? So that then I can go from here to here and say that that's going to be, I measure 2. Yeah, 2 millimeters. The lines themselves, each line in line with the origin. Trim the outsides. Okay, and so there's our section that we're cutting. Then we're going to go extrude cut. The width is 14. The width of the middle section is 1 millimeter, but we're going to go halfway. So we're going to go 14 divided by 2 minus 0.5, 6.5. And then, does it have any, fillets or anything on the edges? In those sort of internal quarters? Maybe a very tiny one. Like in there. And probably on this outside edge. So we'll put those in at some point as we do this pattern. What I want to do is mirror this, because now I'm thinking about how to do this this tread. So how many are there? How many patterns are there? I found this always very difficult. Put my finger on one of them and count. So starting at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 treads. So I want to move. Need to think about this. This is where splitting it and just rotating it seemed to make a lot of sense last time, because I want to do a feature pattern, but if I move a face, that's going to cause me problems. So I think we'll just rotate it afterwards. So we're essentially here doing the same thing I did on the other tread. It's just that the whole design's a lot simpler. So I'm going to do half the wheel. Right? I'm just doing half. I'm going to grab the, you can come back there. I'm going to grab those two and I'm going to do my circular pattern. And we've got 20 of those. And I'm going to mirror this body, but I'm not going to merge it. And I'm going to rotate. So I'm going to select this body. I'm going to go translate, rotate. Yeah, exactly, Arte. That's what I do for this. And that's how I did the last wheel. So now I'm going to rotate it. And because the origin's right in the middle, it makes it really easy. So I'm rotating around. I always look to where my head isn't right now, where the axis is. So I'm rotating around the X. Now I want to rotate, there's 20 instances. So 360 divided by 20 divided by 2 to stagger them. All right, so now they're halved, and then I combine them back together. Get a funny color on this one. I don't know why, but yep, that is done. But I haven't put the fillets in, and so I probably want to put that other fillet in before I do the mirror, at least. Before I do the cut here, I want to put this fillet in. This fillet's going to remove my edge. So there's a fillet on this edge, which we're going to put at like 0.5 millimeter. It's going to cause an issue with this cut extrude because I've lost, yeah, that face. There's 2 sketches here now. I'm just going to convert that. And this one can sit on this edge. Does that make sense? Yeah, close enough. Okay, done that, done that. Also want to put radius on that edge. Yep. Pattern, but I need to include this fillet. Oh, okay, that worked. And then that should be okay now. Something funny with the materials. Hello, David. I'd say make a sketch and measure the angle. I'm not sure which angle you're talking about. I'm pretty happy with the finished tire though. What we can do now is check how it fits against the wheel. All right, so let me just fix this one temporarily. And we'll do a mate of these two. And then face to face. That is the wrong face. I want to do this face. Yeah, so my sizing's a little bit off with these two. Something's going wrong, but we can tweak that. So The inside of my wheel is a tiny bit small. My PC specs, good question. Let me show you. Let me see if I can get it up. Whoa. Here you go. This is what I've got. I'm on right now a Lenovo laptop. Windows 11 Pro. Intel Core Ultra 9. 64 gig RAM. What else can I tell you? I don't know. I'm not big on computer specs. But it does reasonable to run SolidWorks, Google Chrome, OBS Studio, and a few other softwares all open at the same time. But the laptop is 3 weeks old. My old Dell laptop died. The battery stopped working and the motherboard didn't want to do its job anymore. So what's wrong on this one? Maybe the tire. So I'm going to edit the tire. I'm going to just go force transparency. The wheel. Well, what's the wheel diameter? I think it was 17.4. So if I'm on the tire, I want to go into the revolve. And let's drop that down to 3. It's too big. 3.1 is the right size. Cool. You can see how those two parts kind of fit there. Perhaps this needs to get a tiny bit bigger. So it's fitting inside. That looks a lot better. And the length of the wheel looks a little bit off. I did measure it at 14, which is still correct. So maybe the tire outside edge should be 14. I think I need to change that one. Not the tire, sorry. This bit, the wheel. If I have a look at that, and the length of that revolve, I've got 15 there. I think that needs to drop down. 14. Is that okay or not okay? Yep. I'm working on a laptop that's connected to a ThinkPad dock, Thunderbolt dock. And the dock is connected to my ultra-wide monitor and the camera. And this other camera. So that 14 dimension is not quite the full width. So let me put that back to 15. And just measure what it's missing. It's those two there, it's 0.4. So I'm going to change this revolve here, reduce that by 0.4. That should be enough to get a nice fit. Cool. Those are looking pretty good, but the middle looks a bit off now. So I might want to fix that. That's in my tire. What's more likely to be different, the yellow plastic or the tire? Probably the yellow plastic. It's not quite centered on that 14.6 because it should be centered on this. I think that's the one. Yep. Right, that's better. All right. Now we've got a few minutes to finish off, but we've done now pretty much all of our parts. I want to check through the list and get everything ready for assembly next week. So let's have a look over here. Done the tire. Now this blue Technic pin with friction ridges is different, I think, to the tan one that we did. So that's these two parts. Let's bring them up. Something is different about these. So we've done this one previously. Technic pin without friction ridges. Okay. Yep, CAD's the right way around. So I think, what's the friction ridge in the example of these two parts? Let's have a closer look. Blue has the friction ridges, and I think we can see it here. See those little sort of pips on the edge, just right where that gloss highlight is. I think that's the friction ridge. Such a minor detail. Right, but this is the work that goes into the Lego, so that slot's different as well. So those friction ridges, I think what they do is they would slow rotation of the plastic component that they get inserted into. So interesting how they're just that tiny bit different. Like look at those slots, top and bottom. So small, right? If we have a look at the assembly, so those friction ridges are like in these early parts, those steps, joining all those together. I don't know why they need to be friction ridges, but hey, we will make this file. So that's this part here. (6.558). So we're going to save a copy of this one and open it. (6.558). Color. Blue. Copy and open. Our color chart is here. Keep the original open. Just going to edit the color while we're waiting. Drag to this one. Probably not quite right, but that'll do. All right, so we're going to get some of those little ridges in there and change just the visible details that we can see. So these slots, I'm going to be pretty quick on these because they're really insignificant, like for us, for what we're doing. Doesn't matter if these slots are a tiny bit different. So this one's obviously bigger, close to 4 millimeters. So let me have a look. Yeah, let's change that to 4. That's changed both ends. That's fine. The slot that's around on this side, there, that can be 7.4. Oof, too big. $7.4. And those little bumps, those friction ridges on these parts, I'm not going to model them. I'm going to skip those. I think we can do without them for this. They're too tiny to really measure accurately anyway. I just want to at least get that blue part in here. It got off. We have a light bluish grey Technic pin. Half without friction ridges. $4,274, we've already got it. And a tan Technic pin 3/4. We've got it. We're done. Awesome work. So next week, when I put the stream up, we'll have all these parts. What I will do is put them into a Google Drive, and I will share the link. So I currently have a public folder that is accessible for anyone that's on my email list. Public files. It's got all the Lego parts from the off-road buggy. So SolidWorks versions plus step files. So if anyone wanted to do their own version, they didn't have SolidWorks 2023 or newer, you can download the step files and import them and use them. So that's for the old off-road buggy, but I'm going to do the same for the parts that I've created so far in this stream. So anyone that wants to follow along can go through the process of doing the assembly and some of the tweaking of parts that happens once you start to put things together and see what doesn't quite fit. Okay, cool, Jen. Groups of printables now supports searching for files and filtering to step files. Nice. I got to admit, I'm not very up to date with all the different libraries that are out there for 3D printing, like Prusa, MakerWorld, Fangs, Thingiverse. There's so many that, you know, I rarely go searching. I often just build my own stuff when I need to do it. But yeah, I need to get on top of it for sharing and putting together some of these libraries. But yeah, I'm pretty happy with this so far. We've done 5 sessions, so about 10 hours of modeling to get all of these parts done. All right, that's everything we've got, all ready to go. So I'll set that up. I'll send a link out. There'll be a link in the stream, the next one. Yeah, so whenever that'll be, probably next Friday or Saturday. We'll check that out. Thanks to everyone that jumped on and watched. All right, thank you, Jen. I will check it out. Thank you to everyone that jumped on and watched and commented. Appreciate that. And I'll see you next time. All right. Later. Cheers, I'd say.